Okay, eighth graders, 2-8. So understanding the y-intercept of a line. So this is kind of, this lesson really is all about what I showed you yesterday, that right now we've just been dealing with lines that are straight and going through the origin. What does that mean? Yeah, just tell me.
It means that there's a constant proportionality.
Yeah, it's constant. The slope doesn't change. It's always the same. And it doesn't matter which 2 points you would use to calculate the slope. And that formula is, let's see who has it memorized here. Miss Durgan, do you have it memorized? No? Oh my gosh, you guys are going to have it memorized here. I would have called on you, but you're shouting out. That doesn't work. So, Miss DiMattei, do you have it memorized?
Y2 minus Y1 over X2 minus X1. Oh.
You guys need to memorize that. You're going to need to know it. Okay? And not just in the next quiz, but probably for the next quiz and several tests. You have to memorize that. Okay? I haven't decided yet. So, so you can use any 2 points to calculate the slope. And when you have a straight line that goes through the origin, it means it's constant. But not all graphs that you guys look at are going to have a line that goes through the origin. Some of them might look like that. And it's going to have a y-intercept. Remember, this is the y-axis. This is the x-axis. So it's going to intersect right here. And depending on the story of the graph, what they're talking about, whether it's money or ounces or miles or speed, y-intercept will mean something. So let's look at the very first example here. Example 1, determine the y-intercept of the relationship. And holy cow, what name is that? Methilda and her friend are going bowling. Shh. She can rent shoes at the bowling alley or use her mother's old bowling shoes. How can she determine how much money she will save if she brings her mother's old bowling shoes? So over here they give us the price of 1 game, 3 games, 5 games, and 10 games. Then it says, so for the first step it says write the number of games and the cost as ordered pairs. And so they did that here for us. So the x-axis is the number of games, and the y is the total cost. And so if there's 3 games, we're looking at $8. If there's 5 games, we're looking at $12. And so you guys could calculate what the constant of proportionality is, or figure out the slope, which is the same thing. But then they point out here that this line isn't going to go through the origin. If you were to extend the line right here, looks like it's going to go right through that. And they zoomed in, and on the y-axis, this is 2. And so what that means simply is that the y-intercept is 2. It means that the cost of the shoes is $2. So Methilda saves $2 if she brings her mother's old bowling shoes. How exciting is that? Saving $2. Yeah. All right. The try it. Prices for a different bowling alley are shown on the graph. They don't give you an equation. They just show it to you on a graph. How much does this bowling alley charge for shoe rental? So it says the line crosses the y-axis. Y-axis. It looks like it's in 2, so this would be 2. Where do you think it crosses? Looks like it's right between the 2 and the 4, so I would say it's 3. So remember when you're writing ordered pairs, x is always first, y is always second. So what point is that right there? Let me pull a stick here. Miss Kurz, what would that point be right there? That as an ordered pair.
Like 0.
Yep. I think 0, 3 probably. So the line crosses the y-axis as 0, 3. 0, first one, that's the x, 0, 3, and then you'd go up from 0 and it intercepts right there. So the y-intercept is 3. And then in these examples, why does the y-intercept represent the cost to rent the bowling shoes? And I wrote down there is still a charge, even if no games are played. If they don't play any games, but they rent the bowling shoes, that's the cost, because that's what it says right here. The y-axis represents the total cost. So even though they haven't played any games, if x is 0, they still charge $3 to rent the bowling shoes. Look at example 2 here. A robotic assembly line manufactures the set number of parts per minute. It says use a graph to verify how many parts the assembly line manufactures when it first turns on. Well, this one's pretty easy here because you can just go to 1 minute and see that they'll do 12 parts per minute, and you can see it's proportional. So that's a pretty easy example. Let's look at example 3 here. Identify the y-intercept. What is the y-intercept for each of the linear relationships shown? So let me pull a stick here. I'm looking at the very first one.
Miss Jane, will you send Jackson Dorsett to the office, please? Jackson Dorsett to the office. His binder, please.
I guess Jackson Dorsett is coming home. Question, honey?
Do you want me to let them back inside their stuff?
Oh my gosh, yeah.
Oh, shoot. Wait, who was that?
He's on his way.
Yeah.
Tom's on his phone.
All right, so Mr. Hanley, look at this first equation, or not equation, this first graph. It says, what's the y-intercept for each of the linear relationships shown? So what's the y-intercept here? What is it? Yeah, looks like it. So the line crosses the y-axis at 0, 2, so the y-intercept is 2. All right, put up 100 points. Next graph. Mr. Rowland.
Is it 2? I mean, -1?
Yeah, I would say -1. And they tell you right there, it's 0, -1. Okay? And so the y-intercept is -1. And then finally, put up 100 points. The last one, Mr. Thompson.
0.
Yeah, obviously it's going through the origin.
Origin.
So 0, 0. All right. The try down at the bottom of the page, it says, what's the y-intercept of each graph? And then it says explain. Well, I don't think you guys need to explain it, because if you tell me what the y-intercept is, it just means that's where the line is going through the y-axis. Mr. Holmes, this very first one here, what's the y-intercept?
2.
Yeah, I agree, 100 points.
Cool.
Right there through the 2. And the next one, Mr. Perry, what's the y-intercept on this graph? What is it?
0.5.
Yeah, I think so. Yeah, very good. I heard somebody correct. It's a -0.5 because it is below the origin. So a -0.5. So this one you could just put 2, and this one you could put a -0.5. All right. Turn the page. All right, like usual, the essential question, what's the y-intercept and what does it indicate? So you can find the answer right here. The y-intercept is the y-coordinate and the point on the graph where the line crosses the y-axis. There's your answer to number 1. Yes?
For the problems, instead of writing like the y-intercept is, could we just put the number?
Yeah, I'm fine with that. Yeah. Number 2, it says Chelsea graphs a proportional relationship. That tells you a lot right there. Braden graphs a line that passes through the origin. What do you know about the y-intercept of each student's graph? Explain your answer. Well, if it's a proportional relationship and somebody graphed it, you know it's a straight line and you know it goes through the origin. And then it says Braden graphs a line that passes through the origin. So they both go through the origin. Scratch out 3, I'm not worried about that. Circle 4 and 5. Yeah, these are really pretty easy. Circle 6. Yeah, I'm just want you to do that one. Not worried about those. 7 and 8, circle those. Let me pull a stick here. Miss Olson, number 7. Find the y-intercept of the graph. What do you think it would be?
4, -4.
Yeah, this is probably -1, so that's -2, -3. Yep, I would say a -4. Okay. Number 8, 9, and 10. Do 11, A and B. Let's look at 11A just for a moment here. It says the line models the temperature on a certain winter day since sunrise. So notice that at sunrise is 0. And then 2 hours after sunrise and 4 hours after sunrise. And so obviously after the sun comes up, Mr. Holmes, the day is getting warmer. So the line is going to be moving up and to the right. So what's the y-intercept?
4.
Yeah. Even though it just starts right here, I mean, it would extend this way, but the y-intercept of the line is 4. And then, Mr. Holmes, what does the y-intercept represent?
The temperature.
What is it?
Temperature.
Yeah, in degrees Celsius. So 4 degrees Celsius, pretty cold. Okay. All right, circle 12. I'm not worried about A, but I do want you to do B. And then 13 says for each graph, draw a line through the point such that the values of the x-intercept and y-intercept are additive inverses.
What the heck?
What the heck? Maybe you'll have to look that up and see what that means. Although it might be in the back of your book. There is a glossary in the back of the book. And then 14, select one of those.
1?
And that's, oh, well, there may be more than one. Select all that apply. There could be 2 or 3 or 4. So you guys have plenty of time. This is a pretty easy lesson. This was just 2-8. Okay, so I've got a handout. Yeah, you do.
Oh, baby.
2-8. Okay, got it. So some of these questions, I mean, you just look at it and you know the answer. This won't take you that long. This handout is due today. Okay, and then we'll grade the workbook tomorrow.
So this is homework, yeah? Yeah, I got 0.